Alright guys, in this video we are going to look at finding angles using sine, cosine, and tangent. So far we did finding sides. So now we're going to go ahead and find some angles. And notice in this problem we're missing the angle x. So if we are using this angle x, what are these two sides right here, the 6 and the 14? So 14 is opposite the 90, which is always the hypotenuse. And the 6 is opposite of the angle, so that's the opposite side. Okay, so we have opposite and hypotenuse, and what that tells me, and hopefully you know this, is that if I have the opposite and the hypotenuse side, that means that I'm going to use the SOH or the sine function. Because remember, if you look at the last two letters of SOH CAH TOA in each one of these, that tells you which one you're using. So if you're using the O and the H, the opposite and hypotenuse, then you go ahead and use the sine function. See? If you're using the A and the H, the adjacent and hypotenuse, then you're using the cosine function. If you have the opposite and adjacent, then of course you're using the tangent function. So here we're going to use the opposite and hypotenuse, which is the sine function. Okay, so let's go ahead and, I guess that doesn't matter. Let's set up our equation here. So we have the sine of an angle. So we're missing the angle now. So the angle now is what we're missing. So the sine of x is equal to opposite, which is 6, over the hypotenuse, which is 14. So now essentially what we're going to do is we're going to go ahead and look this value 6/14 up in this table of values. So there's a sine column. This is kind of small, but in this sine column all of our values are listed here from 0 basically all the way to the sine of 90 degrees, which is 1. So what ratio is 6/14? And so if we use a calculator here, we can round this to the nearest thousandth. So let's go ahead and calculate 6/14. So we'll use our calculator, take 6, divide by 14, and that gives us 0.429. Okay, so let's go back to our value, and let's continue this equation, and it will be the sine of some angle, we don't know yet, is equal to 0.429. Okay, so now let's go back and look at that table of values. Essentially we're looking up backwards. So we're in the sine column, and it starts here from 1 and goes all the way down, and we got to find 0.429. So 0.429, let me get a highlighter. 0.429 is going to be somewhere right around here. 0.422 and 0.43. So it's going to be between 25 and 26 degrees. Okay, so what we've determined here is that this value, x, is going to be somewhere between, what did I say, 24 and 25 degrees? Yep. So x is going to be somewhere between 24 to 25 degrees, probably closer to 24. Okay, how can we get more accurate than that? Well, you know, this is just looking in a value and doing some guessing, some guesstimating here. And we now have calculators that will help us do this. So if you go to your calculator, we'll go back to that calculator there, and you'll see these functions that have sine to the -1, cosine to the -1. That is the inverse sine button, and that will look up your values just like we looked up in the table, but much more accurately. So if I take 6, divide by 14, and then in this case I have to hit the button after. On the TI Inspires you'd hit this button first and then 6 divided by 14, but this one's different. So now I hit this, make sure I'm in degree mode, and now it gives me my value 25.37, which that doesn't make sense with what we had. Let's go back and look at that value. I thought it was between 24 and 25 based on this value. Oh, I was wrong. 25 and 26. Okay, that makes sense. I was just reading the table wrong. 0.4226 and 0.43. So it's somewhere in between those two, which is in between 25 and 26. And according to our calculator, it's 25.38. So instead of looking it up in the table of values, of course we have calculators, so we're not going to do that. We're going to just go ahead and we're going to type in the inverse, which this just means it's looking it up backwards. So the inverse sine of 6 divided by 14, this is what I typed in the calculator, and that gave us 25.4 something. I forgot exactly what it was. Okay, so that's how you look up these values when you're finding an angle. Let's look at two more problems. Here's another problem, and we're trying to find this missing angle here. So what two sides do we have? Well, opposite of the 90 is over here. That's the hypotenuse, so we don't have the hypotenuse here, which if you've been doing your practice, you might know that we are going to need the tangent function, TOA. It's the only one without the h in it. So we are going to do the tangent. So let's go ahead and set this up. We have the tangent of x degrees is equal to opposite over adjacent, that's 34 over 7. Okay, so 34 over 7, gosh, that's almost 5, right? So I'm just curious, I like to look at these tables. I think it really helps us understand what's going on. But if you look at what angle has a tangent value of almost 5, that's going to be somewhere down here, it looks like. So let me get a highlighter out again. We'll do this. Almost 5, that's going to be somewhere between this value and that value, which looks like it's between 78 and 79 degrees. So when we type this into the calculator, it should be probably closer to 79. So let's go ahead and take a peek at the calculator. I think it was 34/7. So we're going to do 34 divided by 7, and then we're going to do the inverse tangent of that, and well, it was closer to 78, 78.37. So the inverse tangent of 34/7 is 78.4 or 78.37. So to finish writing this out, what we did was we did the inverse tangent of 34/7, and that found our angle x. And then angle x we found to be, let's just double check again there, 78.37. So what that means is, and that makes sense, this angle right here is about 78.3 degrees. Now it might be interesting to point out that if we know that angle, and this is a 90-degree angle, well then we certainly know this angle over here, okay? And these two angles, if this one's 90, these two angles here have to add up to 90. So if I needed to find this angle, I could just subtract 78.3 from 90, and I would have, oh, what is that, 11.7. So if I needed to find that, just need to make sure that these two add up to 90, and that would be 88, 89, 90 degrees. Something to keep in mind there. Last one. In this problem we have, let's see, we do have the hypotenuse and we have the adjacent, which this means A and H, we use our cosine. So let's go ahead and set up the cosine value. So we'd have cosine of x, we're missing our angle here, is equal to A over H is 14 over 17. And to find the angle then, I would do the cosine inverse of 14/17 on the calculator. And that will give you your x. Okay, so 14/17, that's getting kind of closer to 1. So let's go ahead and calculate that. 14/17. 0.8235, and we'll do the inverse cosine. 34.56 degrees. So x is 34.56 degrees. All right, so there's 3 problems using each trig ratio, and that was finding angles.